More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math. Mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Good day, and welcome to the Mathnasium Schoolhouse. My name is Larry. Today we're going to be taking a look at geometry, and the particular aspect of geometry that I'm interested in today is area. So please take a look at this slide. Let me get that up for you here. Here we go. So before we get into the details of area, the formulas and all those things, I'd like to give you a perspective as to where area fits into the big picture of geometry. So the first element we have here in our chart is a point. And a point is zero-dimensional, which means it has no length, no width, and no depth. So that's our basic element in geometry. So now after 0 comes 1, so if we have a one-dimensional entity, what we can do is measure a line. And distance is measured in what we call linear units. Now the word linear kind of disguises what's really going on here. Take a look at the first 4 letters of linear, L-I-N-E, line. So a linear unit is something we measure along a line. So if you look at the pictures here, I said the distance is the amount of space between 2 points. Those could be in a straight line, they could be on a curved line. And what we're going to do in either case is we're going to measure along that line, and hence what we get. So when we think of distance, you could be using inches, feet, meters. All of those are linear units. Now I'll contrast linear units with the next one here, which is area, which is two-dimensional. And area is a measure of the amount of space inside of a closed figure, like that square there with 9 squares inside of it. That's showing that the area of that is measured in square units. So when we're measuring on a line, we're measuring linear units. When we're measuring area, that's two-dimensional, we have square units. And then going from 2 dimensions to 3 dimensions, we go from area, this time to volume. And volume is the measure of the amount of space inside a 3-dimensional figure. And as the figure shows there, volume is measured in cubic units, that is how many cubes fit inside. With area, we're looking for how many squares fit inside. And for linear units, we're looking to see how many of those spaces, inches, feet, whatever those we're measuring in, actually turns out to be the length of the line. So, moving along here, why do we measure things? Well, we measure things to find a number that shows the amount of something. For instance, I may want to know, how tall am I? How much do I weigh? How long until dinner? All of these things are things that we need to measure in one way or another. Now, in the process of measuring things, we're going to come up with a number, and we're also going to come up with what we call a unit of measure, that is to say, a name. So units of measure for distance include things like, as I mentioned earlier, inches, could be meters, miles. And let's get a little perspective on why these units of measure are so important, and that we be very specific about how we say them. On the screen there you can see, I walked 3 blank to get to school. Now if you walk 3 inches to get to school, you probably are homeschooled, because you're not going to be walking very far. On the other hand, if you walk 3 miles to get to school, so the 3 tells us how much, and the unit of measure tells us what we're actually measuring, whether it's, in this case, inches, miles, meters. Also note that the word unit means one. As in United States is one group of states, the universe is one collection of all things. So this idea of a unit of measure, the unit itself is the name of what we're dealing with in terms of measurement. And because we're going to be dealing with area today, we're going to be dealing with units of distance like inches, miles, meters. And depending on whether we're doing length, area, or volume, the units that we report our answer in are different. And this will become clear, I think, as we move along through some of these exercises. An expression that I'll be using quite a lot, and I'm sure those of you who are in 4th grade and above have heard this many times at school. What is a unit square, or a square unit? It's pronounced both ways. So take a look here at picture A on the screen, and that's a garden variety rectangle there. And if we want to find the area inside of that, how are we going to do that? Well, we've got to break it down into things that we can handle, that is, things that make sense and that we can communicate from one person to another. So what math people figured out a while back was, let's break it into equal parts. So as you can see in figure B, this is starting the process. The top line and bottom line have been broken into 4 parts. The sides are broken into 3 parts. And when you connect those little hash marks there, you start to see these squares starting to form in figure C. And when you get to figure D, those squares, boom, pop out. And so if this rectangle, if A would happen to be 4 by 3, which is what this diagram shows, the area would be, and well, how many squares are there? Well, let's see, 3 rows of 4, so there's 12 squares. And so the answer is not just 12. And let's say these were inches. It's not just 12 inches. Because when we're reporting area, what we need is the measure there is square units. So when we break square A down into 12 squares, as we did for D, the area of that is 12 square inches. So whenever you're reporting area, that word square must be in there, because we're not measuring lines, we're not measuring space, we're measuring the amount of space inside of something flat, like on the screen. So square units are going to be the units we're going to be reporting all of our area in. So to do that, it would be really good to have the language of area. And interestingly, their textbooks do it 2 different ways. Some textbooks refer to length and width, and other textbooks refer to base and height. Either way, what we're reporting there is the length typically is the horizontal, and the width is typically the vertical here. And the same thing with the base is the horizontal, and the height will become very important in a little bit, is always vertical. So how do we find the area of a rectangle? Well, so far in most of the rectangles I've been showing you, you can see that the space inside of the rectangle has been broken down into squares. Well, that's going to get a little tedious after a while, so let's see if we can figure out a better way to approach this. I mean, we certainly could sit there and count up all the squares one by one, would be one way to do it. Another would be to take advantage of the fact that there's some multiplication involved here. I've got 9 squares along the bottom, 4 going up. So I could go 9 4 times and get 36. Wait a minute, that was a pretty straightforward way to do it. If I multiply the base times the height, or alternately the length times the width, either way I'm going to get 36. And what are my units here? Well, I'd like to see in the answer column, what's the answer to this question? What is the area of that square? The number is 36. What are the units here? And I've got the chat box open, and somebody would like to chime in here? Okay, square units, yes, very good. So this rectangle is 36 square units. Now again, we could draw the squares in every time, but now we have a formula that's going to allow us to do this without having to actually draw the squares. So let's take a look at a couple of sample problems here, one of which I drew the squares in and one which I didn't. So what's the area of number 1 here? Let's take a look at, no, not 36. 36 what? Remember, we need a number and a name. So what's the area of number 1 here? Got a little bit of time here in the chat box. Anybody like to volunteer? Looks like the chat box is a little bit behind here. Okay, not just units though. The area of number 1, 6 times 6 is 36. And what are we looking at? We're looking at squares. So the answer here is 36 square. Oh, something I forgot to mention. When we don't put inches or feet or yards, and just a number here, the typical thing classroom teachers want our students to do is they would want a student to answer this one, 36 square units. And then if the teacher specified inches or feet or whatever, then that could be plugged in. But a perfectly good answer to this question is 36 square units. Okay, now for number 2, this is going to be a little bit more advanced here. We're not going to draw the squares in this time because Now we know that the area of a square is length times width or base times height, and so we don't need to sit there and look at the squares. What we can do is, in this case, multiply 9 times 6 and get 54, and I'm seeing 36 square units on the screen now for the last one. That's good. What about, so what would this be? Number 2, the number is 54, and what kind of units do we have here? That's what I'm looking for there. Who was that? Rebecca, thank you so much. That's exactly right. 54 square units. So rectangles, of all the shapes we're going to be dealing with, are probably the most straightforward thing that we have. Let's go on and take a look now at a close relative of the rectangle, and that is a triangle. And it turns out that every rectangle, as I've shown here on the left side, can be cut in half to make a triangle. And depending on the shape of the triangle, the beginning is a little different, but the point, a triangle essentially is half of a rectangle. And we know the formula for a rectangle is base times height. So, hey, we only have half of it. So the formula for the area of a triangle is pretty straightforward. It's 1/2 the base times the height. Now, one thing I need to make very clear here, a note about the height of a triangle. When we say height, we're not talking about just like any old line from the top to the bottom. What we're talking about is a line as shown in all 3 of these pictures here. That red line, the height of a figure, a triangle or a rectangle or any figure, needs to be from the top vertex and straight down to the base where it meets in a right angle. Some folks would say that the height is perpendicular to the base. If we want to use that word, that's great, but what that means is that the height meets the base in a right angle, and that's the line we want to measure. More about that in a future video. So as you can see from the picture here, the height of a triangle, as in the first figure, could be inside the triangle. In the second figure, the height is one side of the triangle, and in some cases, as we can see in the third figure, the height is actually outside of the triangle. Again, remember, the height is from the top vertex straight down. And if straight down is outside the triangle, so be it. That's the way that this works out. And we're not going to multiply these out because these numbers are pretty big. But I think you get the idea here. In fact, let's do a couple of problems where the numbers are a little more reasonable. So the height, whoops, I made a bit of a mistake here. That 12 should be the height of the triangle, not one of the sides. My apologies for that. So assuming that that's the height, the formula then is 1/2 base times height. So we could multiply 24 times 12 and then divide the answer by 2, but that's more work, I think, than we really need to do, because if you notice, 24, we can split that in half very easily, and that's 12, and hopefully you know your times tables and know that 12 times 12 is 144. So the area, in fact, let me do that on the whiteboard here. So let me redraw the triangle and redraw it properly this time. Oops. Okay, here we go. Okay, so that's 12 and that's 24, and we do have a unit here. This time it's meters. So the formula says 1/2 base times height, and we can go 1/2 of 24 times 12, and as I said, half of 24 is Hey, Mary, if you're watching, where did we lose the thread? I'll go back to that point. Oh, finally, good. Welcome back, folks. Looks like I need to start this part of this conversation over again. So let me go back to, I'm not quite sure where the video kicked out, but this is a good starting point here. Let me go back to, because this is worth everybody looking at a second time, even if you've seen it before. So the height of a triangle, the height of a rectangle, the height of any figure, again, is from the top vertex straight down to the base. And as you can see in the picture here, that height might be inside the triangle, as in the first figure. It might be part of the triangle, as in the second figure, one side of a right triangle. And sometimes to go from the vertex straight down, you're outside of the triangle, and so be it. That turns out, again, to be the height, because it's always from the vertex straight down to the base, making a right angle. And if you want to use a lot of fancy math words here, we say that the height is perpendicular to the base, meaning they meet in a right angle. So with that thought about height, let's go on and actually do a couple of problems here. And I got a little bit of, let me switch this back to big board, come on. What happened? Okay, so the figure I have on the screen right now, I made an error when I created this. I'm sorry about this. Let me do this correctly. The height was supposed to be 12 and the base 24 meters. So I've redrawn that. Let me show you that now on the screen. Okay, so the formula for area of a triangle is always 1/2 base times height. And in this case, we have 1/2. The base is 24 meters. The height straight up and down is 12. And we could do the multiplication here first, but I find that to be too much work because I look at it and say, wait a minute, half of 24 is 12. And 12 times 12, hopefully you know your times tables to that point, is 144. So that's the number, 144. Now, question, what are the units? Anybody like to pop that into the chat box? So we got a base of 24, a height of 12. It's a triangle, so we're going to go 1/2 base times height. Get our number, and what are our units here? There we go. Thank you, Rebecca. 144 squared meters. You know, technically, by the way, we don't say squared. We do say square meters, but that part really doesn't matter, and because usually it's abbreviated like this: square meters, or sometimes meters to the second power, which also means meters squared. So that's the first example we have here. Let me get back to the picture here. How about the second one now? So how long is the height in triangle number 2? Is that the 20, the 12, or the 16? Which one is the height? Good, 12 inches, excellent. And the base, obviously 16. So what we're going to do is multiply 12 times 16 and take half of that answer. Again, if you have an even number as one of the numbers, it's a really good idea to just divide that out. So instead of doing 12 times 16, I'm going to take half of 16, which is 8, and then multiply 8 times 12. And again, hopefully you know your times tables. 8 times 12 is 96. And so the answer to this one is going to be 96 square inches. And so that gets us through the triangle. Let's kind of stop for a second and see what we've done so far. Well, we know that area is the amount of space inside a two-dimensional figure, and that is always measured in square units. And we know that the units, in this case, are going to be units of distance, which in the English system are going to be inches, feet, yards, and miles. In the metric system, it's going to be meters, kilometers, and all the variations of that. And if we're looking at a rectangle, the formula for that is straightforward, is base times height. And a triangle, being half of a rectangle, is 1/2 base times height. And when you think of those two things together, it makes it a bit easier to remember in the long run. Okay, the last figure we're going to take a look at today is the circle. And the deal with the circle is very different than a rectangle or a triangle. So the first thing we need to do is identify some of the vocabulary of circles. So a circle is a set of points that are all the same distance from a center, from a given point. And that distance, we call that the radius. And as you can see in the picture there, from the center to the outside edge, and no matter where you draw that dashed line, it's always going to be the same length. It's always going to be the radius of the circle. And if you continue that dashed line all the way through, we get the diameter of the circle. One way to remember diameter is to remember that dia means across and meter means measure. So the diameter, or sometimes pronounced the diameter, if you will, is the distance across a circle. Whereas a ray is something that starts at a point and goes outward, like a sun ray that starts at the sun and goes outward. So a radius starts at the center and goes out, and it's half of the circle, and the diameter is indeed the whole circle. And one last bit of math vocabulary here. The circumference of a circle is the distance around. Interestingly, that's the other name for the distance around that we use with virtually every other figure is perimeter. So you can think of the circumference as the perimeter of a circle, that is to say the distance around. And sometimes knowing what words mean helps us to remember things. Words that start off with CIRC, like circumference does, always have something to do with round. The word circus starts with those same 4 letters and literally means a theater in the round. And when air circulates, it moves around. So when you see circa at the beginning of something, the notion of a round is going to be there. And that might help you with making the connection between circumference and the more common word for distance around being perimeter. Okay, so how's this vocabulary going to help us? Well, we need one more little bit of vocabulary here before we can go on and deal with the area of a circle. And that is, what is pi? Well, we all know back on March 14th, 314, that's has been Pi Day for many, many years. And pi is, well, in very formal math language, is the ratio of the circumference of a circle to its diameter. Now, a little bit simpler explanation, with a bit more words but a lot less jargon, is that pi is the distance around a circle divided by the distance across the circle. And when you do that, whether the circle is the size of a dime or the size of the sun, doesn't really matter. If you take the distance around the circle and divide it by the distance across the circle, interestingly, you always get the same number, 3.14159. Goes on, and in fact, the decimal representation of pi goes on forever, and it's called an irrational number because it never stops and it never repeats, giving it a very different characteristic from the numbers we use in everyday life. So with pi, we've got to be, with circles, and because of this situation with pi, we need to be very careful about how we handle things. So sometimes questions involving areas of circles will ask us to get an approximate answer, because there's no way that we're going to be able to multiply an irrational number by anything and get something that we can work with in our everyday classroom. So what math people have done typically is when we want what's called an approximation, that is getting really close to the answer to the area, but not quite, we can either use 3.14 if we want to do it in decimal, or the fraction 22/7 is a very good approximation to pi up to a certain point. And so typically this is what you'll see in your textbooks. Will be, if the answer is to be an approximation, they'll say use 3.14 or 22/7. Other times they'll say leave your answer in terms of pi, and that's called giving the exact answer. And I'll be giving you a few more details on this in the next few slides. But before we go on, let's recap this about pi. So basic at its very core, for our purposes today, pi is the distance around a circle divided by the distance across. That is the circumference divided by the diameter. And sometimes we're going to be asked to give exact answers. Sometimes we're going to be asked to give approximate answers, because pi, being an irrational number, does not have a decimal representation that is easy to work with. So let's see how all that works out in practice now. So to find the area of a circle, formula-wise, is a pretty straightforward deal. The area of a circle is this number pi times r to the second power, that is, times the radius squared. And this usually is pronounced the area of a circle equals pi r squared. And the formula there is pretty straightforward when you look at it. So let's find the area of a circle whose radius is 10. Well, to find an approximate answer here, we can use pi equals 3.14. And I've written out the details here for you. Area equals pi times the radius squared, which is 3.14 times 10 to the second power. And remember, second power means number times itself. So that's going to be 100. And nice thing about multiplying by 100 is what it does is it moves the decimal point over 2 places to the right. And so the area of a circle with a radius of 10 meters would be 314 square meters. Again, always when we're dealing with area, that word square must be in there, because we're not doing linear units, we're not doing 3D units, we're doing square units, which is two-dimensional. Now, to find the exact answer, this turns out actually to be a lot easier than giving the approximate answer. We leave the answer, quote, in terms of pi, and here's what that means. Follow along the formula there. Area equals pi r squared equals pi times 10 to the second power equals 100 times pi, and we're done. So we don't actually give a decimal answer or a fraction answer when we're asked to leave it in terms of pi. And as you move through the grades, you'll see in the lower grades, you'll actually be probably doing approximate answers, but as you move along to upper middle school and definitely into high school, most of the time when you encounter pi, it'll be just giving the answer in terms of pi, which means we don't multiply it out, because for a given problem, we may not know how much accuracy we want. We may want it to the nearest tenth, we may want it to the nearest thousandth. So when it says give the exact answer, we don't concern ourselves with that. All we're concerned about is giving the numerical portion r squared and then that number of square units, in this case meters. Okay, so let's take a look now at these two questions. The first one asks for an approximate answer. So someone like to work this out and pop it in the chat box? That would be very cool. I can't quite see the whole chat box here. Give me a second. There we go. I'm not quite sure what somebody said here. 300, good. Okay, so this triangle with a radius of 28 centimeters, what's the area here? Okay, I'm not, oh, the screen is off again, damn. Oh, there we go. Are we back live again? Good. Okay, what do we have for answers here? That one looks way too big. Let's see. Oh no, sorry, that's fine. Yeah. Through 1,265. Again, let me work this out on the whiteboard. Okay, so we have a circle with a radius of 20. So area is going to be pi r squared, and since we're going for an approximation, we can use 3.14 times 20 squared, and we work that out and we get 1,256 square. And what are our units in this problem? Centimeters. Very good. Okay, so once we deal with this question about do we want an exact answer or an approximate answer to pi, utilizing the formula is not too difficult. It's a bit more arithmetic than we've been used to, but it all works out. How about the second question now? Let me bring you back to that point. Okay, this time we don't have a radius, we're given a diameter. So what do? Well, we certainly don't want to, the formula requires a radius. So we noted earlier that a radius is half of a diameter. So the radius of this circle is 2.5, in this case, millimeters. Again, let me get a picture of this going for us. Okay, let me switch back to that. Okay, so the diameter was 5, so the radius is going to be 2.5. And let's work our formula now. Area. Now this time the question asks us for an exact answer. So it's going to be pi times radius squared, which is 2.5 squared. Now we're not going to break pi into 3.14 or 22/7 because it asks for an exact answer. So we need to leave pi in place and multiply 2.5 times 2.5. And when we do that, we get 6.25, which I'll write as 6.25. And so it's going to be 6.25, and our units were millimeters. So, whoops, that didn't show up too well on the screen, so let me get that. Square millimeters, or we can also write it as millimeters squared. So again, depending on what the question is asking for, whether it's an approximate answer or an exact answer, I think we know how to handle that now. And with all these ideas in mind, let's go back a bit and let's see how area is used in the real world. So let me bring up some questions here. Okay, a flag is 25 by 50 centimeters long. What's the area of the flag? Well, pretty straightforward question here. That flag is presumably rectangular, given the dimensions there. And we know the formula for an area of a rectangle is base times height, or length times width. And so we multiply 25 times 50. Well, let's see, 25 times 25 is 625. And if we take 625 and double that, we get 1250. So that flag is 1250 centimeters. And let me write that on the whiteboard here. So then we'll wear numbers, 25 and 50. So area equals base times height is going to be 25 times 50. And we can, a lot of ways to do this. I look at it like this. Because I want my students to know that 25 times 25 is 625, which is why I like this problem. And then that times 2, 600 doubled is 1200, 25 doubled is 50. And so we're going to get 1250 square, and I believe the units were millimeters. Let me see. I'm sorry, centimeters. Okay, now the next problem is just a bit more involved. And I'll read it out loud, and then let's take a moment and have you work it out. Before I do, I'd like to see some correct answers in the chat box. So Jason's going to paint a 10-foot by 20-foot wall. Each can of paint will cover 25 square feet. How many cans of paint does Jason need to buy? He doesn't want to buy too many. He doesn't want to waste his money. He doesn't want to buy too few because he wants to finish the job. So how many cans does he need to buy? And I will leave that in your capable hands, and let's see what you come up with. Oh, very good, Mr. Julian. Excellent. And Julian, could you type in the chat box how you got your 8? Okay, I'll tell you what, I'll do that on the whiteboard as well. Okay, so, I'm seeing quite a few 8s now, good. Okay, for the benefit of those of you, let's see, 8 buckets of paint. Okay, I like it, Julian. I got 200 for the area. You multiply base times height, that is the 10 times the 20, and that gave you 200. And then divided by 25. And how many 25s are there? You could do that as a long division problem, or you could do it the Mathnasium way, which is to ask, how many 25s are there in 200? Which it's kind of like asking, how many quarters are there in $2? It's the same question, how many 25s in 200 cents? And as Julian correctly told us, that was 8. And so the final answer to the question is 8. And I think I only saw one person who actually completely wrote the answer correctly. Julian, you got 8 for the number. 8 what? 8 centimeters, 8 gallons, 8 quarts, 8 what? Because remember, we're actually always looking for a number and a unit. So what I'm pushing you for there is to say 8 buckets of paint, or 8 cans. Because it's not just 8. This goes on all the time in elementary school, middle school. Hopefully we can get kids over it by the time they leave middle school, of just giving us numbers when there should be a number and a unit. Very good, Julian. Got it covered. Okay, we got one more question here for the moment, and let's go back to the area of a sandbox is 90 square feet. The area of a sandbox is 90 square feet. The length of the sandbox is 10 feet. What's the width? This is a variation on what we've done so far. And for some kids, this kind of throws them for a loop sometimes, but now I don't want to see all those nines there. I keep seeing, I don't know if it looks like a 9 or a G. The width of, Rebecca, there we go. The width of the sandbox is not just 9, but it is 9 feet. Very good. Okay, so let's do a review of some of the language that we've used today, because as I pointed out in other videos, one of the key things in understanding math is understanding the vocabulary. So the first thing we introduced were point, distance, area, and volume. A point is a location, like a GPS position. Distance is measuring along a line, a straight line, a curved line, and those kind of units are measured in linear units, that is, along a straight line. Area, as we saw, is a two-dimensional creature, and different textbooks say it different ways, but it could be length times width or base times height for the area. And that's the two-dimensional entity, because we're always dealing with area on some kind of flat surface. And then when we're dealing with things in three-dimensional space, what we're looking for is the volume. And so volume is a three-dimensional entity, and the units there are cubic units. We're measuring how many cubes we can put inside of a figure, whereas with area, we're looking to see how many squares it takes to cover a particular area. With distance, we're looking to see how far apart two particular points are. A unit, the next vocabulary word here, as I pointed out earlier, UNI typically means one. So a unit is the one, like 1 foot, 1 inch, 1 meter. And a square unit is, instead of being just a line that's that long, it is a square with with each side is 1. Length and width are both 1. And then, as I've mentioned several times, length and width and base and height are two different ways to express the size of a rectangle. Mostly the one we want to go with a lot of the time is base times height, because that height carries over into triangles, carries over into other geometric figures. And then with a circle, we need a couple of more vocabulary words. Radius, the distance from the center to the edge, that is from a point outward. And the diameter, the distance across the circle. And finally, we have all of that boils down to these three formulas. The formula for the area of a rectangle, base times height. Area of a triangle, 1/2 base times height. And finally, a circle being pi r squared, or pi times the radius times the radius. So I hope you have a couple of significant takeaways from today. The first are the formulas themselves, which many kids actually know, but then the extra step and the extra thinking that goes into, so you got 25 what? Was it inches, square inches, cubic inches? The correct answer in math pretty much always has a number and a name associated with it. And with that, I'd like to thank you all very much for joining us today for this presentation at the Mathnasium Schoolhouse. This week, we're going to be having more presentations involving other areas of geometry. So we hope you join in for that, and I'll see you next time at the Mathnasium Schoolhouse.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do 1/2 of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.